Hello everybody. In this video we're going to write out the Lewis dot structure for arsenic trifluoride. We'll start by writing out the different types of atoms that we have. We have arsenic and we have fluorine. Next I'm going to want to write out their electron configurations. If I come down here, we can see that we have arsenic here, 4s2, 3d10, 4p3, and then that's going to have an argon core. So we come up here, we write out our argon core, 4s2, 3d10, 4p3. We come down here and just double check ourselves to make sure that we're right. I always do that when they get a little bit more complicated, just to make sure that I'm good. Then we need to write out the electron configuration for fluorine. If we look at fluorine, it's here, 2s2, 2p5, it's got a helium core. I'm going to write out helium, 2s2, 2p5. Now, if we look at this for a moment, arsenic is a main group, okay, which means that the only ones that count as valence electrons are the ones that have the highest N number. So if we look up here, the highest N number is 4, which means that none of these 3d10s count. So we're not going to count those this time. And we're going to add up these subscripts here to come up with 5 valence electrons for arsenic. And then this one, also main group, but we're just, the highest is 2 for both of them, so we get to add them all together. We're going to get 7 valence electrons for that guy. Now we need to calculate our bank. How many total valence electrons do we have? We have 1 arsenic at 5 electrons plus 3 fluorines. Each of those is giving us 7 electrons. So 21 plus 5 is 26 electrons altogether. Now we need to draw our skeletal structure. We want to place the least electronegative one in the center. Fluorine is the most electronegative element that there is. It's always going to be terminal. We don't typically put fluorine in the center, which leaves arsenic as our central atom. We're going to place arsenic in the center. And I need to attach that to 3 fluorines, so I'm going to draw a little spoked wheel around that arsenic with the fluorines. I had 26 electrons in the bank. I just made 3 bonds, so I need to burn 3 bonds worth of electrons. And I'm going to be left with 20 electrons. Those 20 electrons need to go onto these fluorines. If I examine this for a second, this fluorine has 2 electrons already. He can take 6 by the time he gets to his full octet. So that's exactly what I'm going to do. I'm going to give him 6. I'm going to give him 6, and I'm going to give this guy 6. That was 3 times 6, 18 electrons. I had 20 in my bank, so I go to 20 electrons minus the 18 electrons I just placed. I'm going to have 2 electrons left over. Now if I put those on any one of the fluorines, I'm going to expand their octet. So where I want to put that last lone pair is going to be on the arsenic now. Now let's just double check that our fluorines do have their octets. So 1, 2, 3, 4, 5, 6, 7, 8. And they're all the same, so they're all going to have their 8. Let's look at arsenic's perspective here. He's got 1, 2, 3, 4, 5, 6, 7, 8. Arsenic is also happy. Everybody has their octet. So this is going to be our proper Lewis dot structure.